Hi, good day. This is Novi Alcover, and we'll be discussing all about the sides and angles of a polygon. That includes the problems involving them. So let's start classifying polygons. I guess you already know the different kinds of polygons. These are the different kinds of polygons from the triangle until the decagon. The sides involves n-gon, that's 12 or 20. Let's have the parts of a polygon. There are 5 parts of a polygon. That's the vertex, the side, the diagonal, the height or the altitude, and the angle. The vertex is the point at which the two sides meet. This one, you could have the vertex on the other side or in here. Side, any of the line segments forming the polygon. This polygon has 5 sides, so this is a pentagon. The side, I guess you already know what side is. Diagonal, line segment drawn from one vertex to another vertex. This one from here until here. Or maybe you could draw a diagonal from another part of the polygon. It could have in this side to this side. Height or altitude. Height or altitude is a line segment drawn from one vertex perpendicular at a right angle to the opposite side. When we say perpendicular lines, you can form a right triangle with it. So that's the height or altitude. The next one is the angle. The angle is formed by two line segments and a vertex. As you can see, there is a vertex in here, and in that arrow curving, that's the angle. So let's have, if a polygon has n sides, n number of sides, then the 1/2 of n times n minus 3 diagonals can be drawn. So diagonals, or getting the diagonal, is 1/2 of n times n minus 3, where n is the number of sides. Let's have an example. How many diagonals can be drawn in a polygon having 12 sides? Let's have solution. Number of diagonals is, we already know number of diagonals, its formula is 1/2 n times n minus 3. So for n is equal to 12, that's n is the number of sides, that's 12. The number of diagonals is 1/2 of 12 times 12 minus 3. That is 6 times 9. 6 times 9, that is 54. So therefore we have 54 diagonals on a polygon of 12 sides. Interior angles of polygons. Interior angles, when we say interior, it's on inside. It's inside of the polygons, inside angles. Let's have this pentagon with its diagonals, or with dividing into triangles and its degrees. The sum of the interior angles of a polygon is n minus 2 times 180. As you can see, we've divided this pentagon into 3 triangles. We made it 3 triangles. That's n minus 2 times 180. Why n minus 2? As you can see, we can't draw a triangle or a diagonal from this side to here. to adjacent side. You can draw diagonals on adjacent adjacent vertices, so that the pentagon is five sides minus 2. That's why we have 3 triangles, where n is the number of sides. Why are we multiplying it by 180? Because each triangle, that's a universal fact that every triangle has a total or a sum of 180 degrees. Let's have an example. Find the sum of the interior angles of a regular pentagon. Let's have the solution. N minus 2, that's 5. Pentagon is 5 sides. 5 minus 2 is 3. You can see 3 times 180. 180 is the sum of degrees of a triangle. So 3 times 180 is equal to 540 degrees. So therefore, the sum of interior angles of a pentagon is 540 degrees. Note, regular polygon is all sides and all angles are equal. The next one. Quadrilateral, pentagon, hexagon, heptagon, octagon. We have a table in here. There's a name of a polygon, number of sides, number of triangles, and sum of the measure of interior angles. Above we have illustrations based on the table. Let's have quadrilateral. You can see quadrilateral 4 sides. 4 sides, getting the number of triangles is divided into 2. Let's divide it into 2. You draw a diagonal across it. That's 1 and 2. The sum of interior angles, so that's 2 times 180 is equal to 360. Let's have pentagon. We already had pentagon. That's 3 times 180, 540. Hexagon. Hexagon has 6 sides. 6 sides. Number of triangles, 4. Why 4? This has n minus 2. So 6 minus 2 is equal to 4. 4 times 180 is equal to 720 degrees, and so on. Next one, exterior angles of a polygon. When we say exterior angles, that's angles formed outside the polygon, outside the regular polygon or on the irregular polygon. Let's have this illustration. As you can see, the illustration has blue angles on it, blue colored angles and red colored angles. That's the interior and exterior angles. The sum of exterior angles of any polygon, one for each vertex, is 360 degrees. So if we're going to total, or we're going to add these angles, the blue colored angles, that is equal to 360 degrees. Now let's have an example. There is an example. Find the value of an exterior angle of a regular pentagon. As it's pentagon again, sum of exterior angles, total of exterior angles is 360. What is asked is the value of each of an exterior angle. So 1, the measure of 1 exterior angle. Let's have 5 exterior angles is equal to 360 degrees. So what we are going to do is to eliminate 5. We divide both sides by 5. So that's 5 exterior angles divided by 5, that's 1 or an exterior angle, 360 divided by 5 is equal to 72 degrees. I guess that's it. Thank you for watching and listening. Again, this is Miss Novi Alcover. Have a good day.